Hi, my name is Alex Goss. I am a junior here at Yale, and I'm a biochemistry and biophysics major. I'm the president of the Yale Undergraduate Rover Association for 2015 and 2016.
And I'm Ian Woolley. I am a junior econ major here at Yale, and I am the finance sub-team leader.
So this year we've had a really good year in terms of how much work that we've gotten done on the Rover. We got 14th place our first year and then 10th place last year, so this is going to make it our third year in the competition. However, in past years, we've had a lot of trouble getting our Rover finished by the time the competition started, and we've had to do a lot of work leading right up to the competition. This year, though, we've been able to really be on task, and we should have a Rover completed within the next 3 weeks, which will be really great.
This year, we've been partnering with the Yale School of Engineering and Applied Sciences, just as we did this past year. We also received funding from the Yale President's Fund, as well as the sponsorship with Alcoa. And of course, none of this would be possible without our amazing sponsorship and partnership with ProtoCase.
So if you look behind me, we have the Yale Center for Engineering, Innovation, and Design. This is where we do a lot of the work on our Rover in terms of planning and shop work. Let's go ahead and take a look inside and see what our sub-teams are up to.
So we made our wheels last year from large pieces of PVC pipe. They worked pretty well, but they had a lot of issues. But we had a lot of issues with the time it took to manufacture them because we were doing it all by hand. This year we decided to go with commercially available large-scale RC car wheels, RC car tires that we're then going to be attaching to 3D printed hubs. This is going to let us cut down on the time to manufacture them by a pretty large amount. As well as give us a lot more traction.
Last year we struggled with a limited field of view, so this year we added a pole mount in the back so we could locate the camera farther and more posterior to give a greater field of view to allow navigation.
The bonus of the single suspension system is that each wheel has its own sort of suspension, that makes it so that way you can remove the middle two wheels, which reduces the weight dramatically, allowing us to move a lot more faster. Sorry.
So for the 2015 URC, we had a really great communication system with a 2.4 gigahertz Ubiquiti rocket radio. This is the radio here. It has two small omnidirectional antennas, fits right on top of the Rover, and it communicates with the BeagleBone Black that's inside the Rover. This also communicates with the radio station here at the base on the back of our 120-degree Omni antenna. This antenna provides a 120-degree radius for the Rover to move within during the competition, and this radio here allows the Rover to move around freely behind obstacles, etc., and still pick up a signal.
The main purpose of the software is to integrate with sensors and control all the motors on the Rover. Last year, our code was mostly written in Python, and it was extremely stable, so we're continuing with that this year. One of our challenges last year, though, was we had a fair amount of difficulty controlling the Rover. The parameters weren't very easy to tune, and this led to large problems with controlling the drive motors and also manipulating the arm. This year, we're focusing on making our code more tunable so that before the competition and at the competition, we can make fast changes and be more responsive to what's happening in the minute.
Hi, I'm Maddie. I'm a freshman chemistry major here at Yale, and I'm head of the Earth Science team. So last year we had a really good showing, and we want to continue to improve upon that. And so we're going to use a lot of the same things. We're going to use a humidity sensor and a temperature sensor also, the same microscope, and then this is our scale for measuring the weight of soil samples, and a direct pH meter, so we don't have to put anything in solution. We can just take the pH right from the sample. Something new we're really excited about this year is a methane sensor, and then also an auger. Last year we had some problems with using our scoop to get into the soil because it was so hard, so we're going to use an auger this year and drill into the ground to get that. And then we also this year met with a professor and got some direction as to what resources to look at and what things to test.